All right, so let us begin. This is our video on calculating molar mass of compounds. And we're going to go from a simple case to a more complicated to an even more complicated case to try to illuminate some of the concepts we talked about in the lecture with the PowerPoint slides. So for the first compound, we're going to do potassium bromide, KBr. And what we need to know for these two elements are their atomic masses, which we would get from a periodic table or a chart. Potassium has an atomic mass of 39.10 grams per mole, and bromine has an atomic mass of 79.90 grams per mole. And you will always have access to a periodic table, whether our quizzes and exams are online or whether they're in person. You're always going to have a periodic table, and the periodic table I like to use has 2 decimal places for each element. Just kind of keeps it simple. So if we want the molar mass for KBr, all we're going to do is we're going to take the potassium molar mass of 39.10 grams per mole, and we're going to add the atomic mass of bromine, 79.90 grams per mole, and our answer is going to be 119.00 grams per mole as the molar mass for potassium bromide. Again, like I said, this one is fairly straightforward. So we're going to increase in complexity as we go from here. So the second one that I want to do is the compound Na3PO4. And there's a couple of twists here because we have multiple ions or multiple atoms of a couple of our participants, and so we need to account for that. And the way I like to do those is the same method that I did above, where I like to put all the different elements on the left, and the next thing I like to do is to put the number of them that are in the compound. So for sodium, we have 3 atoms of sodium in sodium phosphate. We have 1 atom of phosphorus because there is a 1 here, but when it's a 1, we don't write it. And for oxygen, we have 4 atoms of oxygen. And I can get that from the formula each and every time. There is no trick. Then we go to our periodic table to get our atomic masses. For sodium, it's 22.99 grams per mole. For potassium, we have 30.97 grams per mole. And for oxygen, and you're going to use oxygen a lot, so you will get to know oxygen, we have 16.00 grams per mole. Then we just do some multiplication. 3 times the 22.99 gives us 68.97 grams per mole from the sodium. 1 times 30.97 gives us 30.97 grams per mole from the phosphorus. And 4 times the 16 gives us 64 grams per mole for the oxygen. And then we're just going to add those numbers together. And we're going to get 163.94 grams per mole for sodium phosphate. Again, a little more complicated because we have some non-1 atoms in here. We have 3 sodiums and 4 oxygens, but it's nothing we can't handle. It's simple math. It's just some multiplication. And then finally, let me put my divider in here. Let's go to, of the 3, the most complicated example I have for you today. And it's a compound called aluminum sulfate. But because of the oxidation states, aluminum is a +3 ion. Sulfate group, you should know, is a -2. So the -2 shows up as we need 2 aluminums. And because aluminum is +3, we're going to need 3 sulfate groups. So again, follow the same process. Write down the 3 elements in this compound. And obviously sometimes there'll be more than 3, but for right now we have 3. And how many aluminums are in aluminum sulfate? Well, conveniently, we have that 2 there, so it's going to be 2. The sulfate is the tricky part, because if I just look at the sulfate, it looks like there's only 1 sulfur. But this 3 multiplies everything inside of these parentheses. So I really have 3 sulfur atoms in aluminum sulfate, and I have 3 times 4 or 12 oxygen atoms in the sulfate group. And now that we've accounted for all of our atoms, we can put our molar masses in. Aluminum, 26.98 grams per mole. Sulfur, 32.07 grams per mole. And oxygen, again, 16.00 grams per mole. And now we do our math. 2 times 26.98 is 53.96. 3 times 32.07 is 96.21. Let's make that look like a 2. And 12 times 16 is 192.00. And yes, these are all grams per mole. And then, now that we've done the multiplication, we just have to add these together. And they add up to 342.17 grams per mole. And that is our molar mass of aluminum sulfate. Feel free to watch this as many times as you need to. I encourage you to do homework problems that look like this, where they ask you to calculate the molar mass of compounds, because you will be doing molar masses of compounds both semesters if you are with us the whole time. And feel free to contact me, come to office hours, any way you can get a hold of me if you're struggling with this. But practice is the thing that's going to make this perfect. Take care. Bye-bye.